Izabel and Julia.
Today's lesson is
balancing equations.
So the definition for balancing equations is putting coefficients in front of molecules to make equations balance. So that means having the same number of every atom on both the reactant side and the product side. So now that we have put the coefficients in front of the elements, it becomes a balanced equation. And a balanced equation is an equation for a chemical reaction in which the number of atoms for each element in the reaction and the total charge are the same for both the reactants and the products. Here are a few tips to remember when balancing an actual equation.
Try to save elements by themselves until last. Start with something that only appears twice.
Start with the most complicated compound. And finally, treat polyatomics as single entities. I'll show you now how to do an actual balanced equation step by step. So to start off, first I write out how many of each element I have. So I have one C, two O's, two H's, one O, two O's, 6 C's, 12 H's, and 6 O's. So as we can see now here, that we have a total of 3 O's on this side and 8 O's on this side. So we need to now insert the coefficients that we believe will be able to be multiplied by these numbers to equal the same amount on this side. So I'm going to put the coefficient of 6 here. So when I multiply the 6 to these, I end up with 6 C's and 12 O's. So I'm going to insert another 6 here. So I now have 12 H's and 6 O's. Now I move on to this side. I'm going to insert, I see here that I have 18 O's in total now after we inserted the coefficients. So I'm going to put a 6 here, and that is going to give me 12 O's. And if I put a 1 here, that is going to give me 6 C's, 12 H's, and 6 O's. Now that I have inserted coefficients, I'm going to add up the same elements, so the O's here and the O's here, and see if the numbers that I ended up with after I added the coefficients on the reactants and the products are the same. So we have a total of 18 O's, 12 H's, and 6 C's on the reactant side. And on the product side, we have 18 O's, 6 C's, and 12 H's. So now I'm going to check to make sure that my numbers match. 18 O's, 6 C's, and 12 H's. And that is how you balance an equation.
Examples for you to try on your own. You can pause the video so you have more time to answer them. Here are the answers. For the first problem, you start with 2 H's, 2 O's, 2 H's, and 1 O.
So when you add the coefficients of 2, 1, and 2, you end up with 4 H's, 2 O's on the reactant side, and 4 H's and 2 O's on the product side. So if we check, here we have 4 H's on the product, 4 on the reactants, 2 O's on the reactants, and 2 O's on the product. So this is a balanced equation.
For the next problem, you start off with 1 Al, 2 Br, 1 Al, and 3 Br.
So when you have the coefficients of 2, 3, and 2, you end up with 2 Als, 3 3 times 2 is 6, so 6 BRs. And on the product side, you end up with 2 ALs and 6 BR. So once again, we check to make sure that they are the same. So we have 2 ALs here, 2 ALs here, 6 BRs here, and 6 BRs here. We now have a balanced equation.
Hello everyone. Today we will be creating a lava lamp. This is a fun experiment you could try at home and is perfect to show what chemicals react and what don't.
For this experiment, we'll be needing a water bottle, vegetable oil, food coloring, and Alka-Seltzer. First thing we'll be doing in this experiment is filling this large beaker 1/4 of the way with water, and then we'll be filling the rest with vegetable oil. You could also do this at home with a water bottle.
The next thing you have to do is add about 8 drops of food coloring in the beaker or water bottle. Next, you're going to take your Alka-Seltzer tablets and break it into 2, so it has a larger surface area and therefore a bigger reaction. And then you just drop it in, and voila! You have a lava lamp.
Now we'll explain what happened in this experiment. The oil didn't mix with the water because it's lighter, and then when the food coloring dropped down, it dropped down to the bottom because it's mostly composed of water.
When we cut the Alka-Seltzer surface area, it was greater. Because of the greater surface area, it made the reaction happen faster. The piece of Alka-Seltzer tablet you dropped in the water after it releases made small bubbles of carbon dioxide gas that rose to the top and took some of the colored water with it. The gas escapes when it reaches the top and the colored water falls back down. The reason the Alka-Seltzer fizzes in such a way is because it contains citric acid and baking soda, and the two react with water to form sodium citrate carbon dioxide gas. Those are the bubbles that carry the colored water to the top.
So as we previously saw, the experiment done was Julia and Daniel created a lava lamp. And the way the lava lamp relates to what we have been learning in this semester is by cutting the Alka-Seltzer in half and putting it into the water and the oil, it created a larger surface area. So, for example, if you have this eraser and this eraser is going to cause a reaction, the surroundings of this eraser is the surface area. So by cutting the eraser into a lot of little pieces, it creates a larger surface area, causing for there to be more reactions to occur in the reaction.
The chemical reactions shown in the experiment included no reaction between water and oil. We know this because the water and oil did not mix, and a reaction between Alka-Seltzer and water. When the Alka-Seltzer tablets fall into the water, they cause bicarbonate to form, which then reacts with hydrogen to form water and carbon dioxide gas.
Thank you so much for taking the time to watch our video on how to balance equations. We hope you enjoyed it.
See you next time on Science Time
With Izabel and Julia.
And me.